All right, good morning. Today we're going to talk about how to calculate molar mass. In the last podcast, you learned about average atomic mass, and average atomic mass is calculated from the isotopes of the elements, but we don't really do much with individual isotopes because we don't work with individual atoms, they're too small. So, what we're going to do most of the time is talk about the molar mass, which is the mass of a whole bunch of them. And we'll talk more about what a mole is later on when we get to the unit on moles. But we just wanted to give you a little introduction to molar mass here, where we've been talking about individual atoms. Thought you ought to see something that's a little bit more practical, which is working with groups of atoms. So the atomic mass technically would be the mass of a single atom. But we use that average that we learned about in the last podcast, the weighted average of all the isotopes. So even though there is no single atom that has that mass, the average atom would weigh that much. What we want to weigh is on a balance. So we've used a whole bunch of atoms, and we just added atoms until that mass of all those atoms equals the same number as that average did for the single atom. Essentially, it's the same thing that you already learned about, just different units. So the atomic mass technically would be in AMU, atomic mass units, and molar mass we will talk about in terms of grams, something we can easily measure on a balance, per mole. That's just how many of them there are. You don't have to worry about that for right now. Where do you find that information? Periodic table. Love it, my best friend. So this is the periodic table, and all these little decimal numbers on here, those are the average atomic masses. But they are also the molar masses for the elements. The number up here, remember, is the number of protons. So the number below, this is our periodic table that we'll use for our test. These are the average atomic masses, average molar masses. So if I were looking for the atomic mass of carbon, here's a picture of what it looked like on the periodic table, more or less. Carbon is 12.01 AMU. It's also 12.01 grams per mole. Fluorine, 19.00 AMU, 19.00 grams per mole. Sodium, 22.99 AMU, 22.99 grams per mole. You get the idea. Very simple. And that works perfectly for elements. We do, however, have to work with compounds as well. Simple also, but we're going to have to put the elements together when we're working with the compound. So the formula of a compound shows how many of each type of atom, and it shows what kinds of atoms we have in the compound. For example, water. Water has 2 hydrogens and 1 oxygen. So we would add 2 of the H's and 1 of the O's together to form the mass. The subscripts tell us how many of the previous species. There's no number after the oxygen, so that's an understood 1. So we would just add the molar masses of each of these. For our water example, we've got 1.01 as the molar mass of hydrogen. We have 2 hydrogens, so 2 times 1.01 would be 2.02 grams per mole. That's for the hydrogen part of the water. We also have the oxygen part. Oxygen is 16.00, so the molar mass of oxygen would be 16.00 grams per mole. Add those 2 together, and we get a molar mass for water of 18.02. That would be true of any pure sample of water you find anywhere, be it here or in Paris or on Mars or anywhere you look. It will be the same molar mass of water because all water has 2 hydrogens and 1 oxygen in it. If there are parentheses in your compound, just like in math, you're going to distribute inside the parentheses. And the subscript goes to whatever is immediately preceding it. So you will distribute the subscript to every species inside the parentheses. Calcium hydroxide would be an example. We've got 1 calcium, but the oxygen and hydrogen are inside the parentheses with a subscript outside. So the subscript 2 applies to both the hydrogen and the oxygen. So you've got 2 oxygens, 2 hydrogens, 1 calcium. To calculate its molar mass, we have 1 calcium. If you look on the periodic table, it is 40.08 grams per mole. Oxygen is 16. There are 2 of them, so we'll double that, make it 32.00. And the hydrogen, 2 times 1.01 gives us 2.02 grams per mole. Add those all up, and we get 74.10. Thinking about sig figs, do I need the 0 at the end? Yes. Yes, I do. Why? Because each of these numbers has 2 decimal places, and we would trim it to the same number as the least. They're all the same, so we need this one to be the same also. Correct answer is 74.10 grams per mole of calcium hydroxide. Your turn. You've got a worksheet to do, molar mass worksheet, and then take notes if you forget how to do it. This is super easy, so I'm pretty sure you'll be fine. But ask me